So we're going to keep practicing Crammer's rule. This time we're going to use it on a 3x3 system, meaning that we have 3 equations with 3 variables. If you can imagine, if it's called a 3x3 system, we're going to have a matrix that is 3x3 because I have a column for each variable, x, y, and z, and then I also have a row for each equation, and I have equation 1, 2, and 3. So that's kind of an easy way to remember. That's what that 2x2 or 3x3, when we see that, it has to do with the number of variables and the number of equations. All right, so with this one, use Crammer's rule on the calculator provided to find the value of y that satisfies the system of linear equations. So they give us these 3 equations, and note Alex's graphing calculator can be used to make computations easier. So we'll take a look at the calculator in a moment. First, I'm going to teach you how to do this on paper so that you understand what is happening. So we're considering a system of equations with linear equations with 3 equations and 3 variables. So we write the coefficient matrix and the constant matrix exactly like we did with 2x2. It's still the exact same thing. It's just going to be the coefficient of each term, and then we also have the constants matrix on the end. We just have a 3rd row this time. Make sure they are in order. It needs to go x, y, z, x, y, z. If I'm missing something, so I can see there's no x here, what that means is it's going to be 0 since it's missing. So if we go to the next page first, I think I'm going to write the constants matrix just so I have it, because I'm going to bring this down. So again, in my brackets, all I'm going to do is grab the constants for equation 1, 2, and 3. So it's 1, 5, 4. And we're going to go down to the next page so that we can build this coefficients matrix really quick. So remember, I'm just grabbing the pieces, the coefficients. So for that first equation, it's -2, -5, -3. For the second equation, it's 5, -5, and 1. And then just like I talked about, x is missing, so that's why it's 0 within the matrix. I need to account for that space. So it goes x, y, z. So 0, -4, and then 1. When I have a 3x3, when we're finding the determinant of a 3x3 matrix, I have to mirror the first and second columns to be able to cross multiply correctly, because I can't simply just cross multiply like this. I have to actually go all the way across from corner to corner. So since I'm multiplying 3 numbers here, I'd only be multiplying 2 if I did cross here, and then I'd only have 1 if I stopped here. So the pattern requires that I mirror it. So I literally just take the first and second column and rewrite them again on the outside. So it's kind of mirroring on that last variable there. So now I can cross multiply. So I'm going to go -2, -5, and 1. So here I get 10. -2 times -5 is 10, times 1 is 10. And then I get the next one, -5 times 1 times 0. Well, anything times 0 is going to be 0. -3 times 5 times -4. So that one's a little bit bigger. You could go 5 times -4 and you get -20 times -3. Just kind of help you do that mental math a little bit there. And you get 60 because there's 2 negatives here. So now that I've cross multiplied going down, I'm going to add those numbers. So 10 plus 0 plus 60 is 70. And now I'm going to cross multiply going the other way, because remember when we did this with 2x2, we went down and we crossed over. So we still have to cross over that way. So now I'm going to start at the 3, and I'm going to go -3, -5, and 0. Well, anything times 0 is 0. -2 times 4 times -4. Sorry, -2 times 1 times -4. That's going to get us +8. And then we're doing one more time, -5 times 1 times, sorry, -5 times 5 times 1. I keep skipping over that middle term. So -5 times 5 is -25, and then times 1 doesn't change that. So I'm going to do the same thing. I'm going to add these terms. So these are the 2 that we subtract. I'm going to subtract 70 and 17. So it's a little bit more involved. As you can see, I had to do quite a few more calculations there to get to these numbers. So 70 minus -17, remember this is going to become a plus, so I get 87. So I need to scooch that up, I guess, because that's supposed to say next page. So we're going to go to the next page. Now this was just the determinant. So all we're being asked to do is find the determinant, well, on this page. We'll answer is they want to know what the value of y is. They're not actually asking what the value of x, y, and z, just y. So if I go to the next page here, I'm going to show you how to use a calculator to do this. Well, that is a lot of steps. We can use the calculator to complete this task. We went over the process because it is important to understand what's happening instead of just blindly using the calculator without really understanding what the calculator is doing. But that is definitely a lot more steps than the 2x2. So we're going to go to the calculator. You can see this is on your notes page, so you should be able to see this. You're going to click on the matrix. Down here, you can see I've circled it on your calculator. So this is on Alex. You click on the calculator, open it. You should see the matrix button. And then click DET for determinant. And then it'll open this page up, and you're going to change 2x2 to 3x3. So we want to click the little drop down button and go 3, and click this one and go 3, just to let it know that we're using 3 columns and 3 rows. And then click OK. And that's going to enter the matrix. So it's going to be empty. I need to enter -2, -5, -3, 5, -5, 1, 0, -4, and 1. If you notice, that matches exactly the problem we were just doing. And if I click equals, we get the 87. So, you know, still a few steps. I still have to know how to get into the matrix on the calculator, but definitely quite a bit easier to use that calculator. So I just have to click matrix, determinant, change the columns and rows so that I have the correct number, and then enter the matrix and hit enter. And it will give me my determinant. So I'm going to show you that on a video, I believe. So now you can see me, I'm clicking the matrix, there's determinant. I already had these changed, that's why they're already 3 and 3, but I'm just showing you the drop down. And now you can see me typing in the matrix. Takes me a second to get over to the numbers. -2, -5, 1, oh sorry, -3, 5, -5, there's the 1, and 0, -4, and 1. And all I have to do is hit equals. And ta-da, it calculated it for me. So that only took a second. You know, took me all of about 30 seconds to do that, as opposed to going through all those other calculations on that other page where I had to cross 3 times going down from left to right, and then I had to cross 3 times going down from right to left. I have to remember to add the 3 from the first and add the 3 from the second, and then subtract those 2 totals. So definitely quite a bit more to remember if I'm doing this on paper. So from here on out, I believe I'm going to use the calculator just because it's there's less room for error using the calculator for that. So on this one, we're going to continue. This is actually on the next page of your notes page, but I'm going to go ahead and continue it because it is the same exact problem. So in the coefficients matrix, the column represents the x, y, and z values. Remember, so we have x, we have y, and we have z. So we can find the x, y, or z determinant by replacing the specific column with the constants matrix and then using the cross multiplication. With this one, here's the original matrix. And here is the constants matrix that I wrote back there on that first page. And I'm going to replace the y column, because remember, that's the column they want. The original question asked only for the y value. So I'm going to replace this y column with the constants matrix. So here it is. We have it replaced. It's 1, 4, 5 instead of -5, -5, -4. So now you can use your calculator to get the determinant of y value, or the y determinant value. So remember, you just go to matrix, determinant, make sure it's a 3 by 3, type this guy in, and click enter. And once we are done, oh, it looks like I did do it on video. So I'm doing it again. Boop. And you can see you don't have to change the 3 by 3 once I've already done that. It comes up. So now I'm just typing in my matrix. And yes, it takes a second to type in the matrix. Make sure you're paying attention to the numbers. Even if you type in one number incorrectly, it will calculate it incorrectly. So make sure you're paying attention and typing in all the numbers in the correct places. So I get -67. So now I can fill it in. I know it's -67. So the value of y is going to be -67 over 87. And again, I don't reduce that because they're prime numbers. They're not going to reduce nicely. I would have to reduce them into a decimal. So that is the value of y for this problem. So we're going to try that one more time. We're going to do an example problem here. So we get a new matrix, 4x minus 4y plus z equals negative 2, 5x minus 2y plus 5z equals 5, and negative 4x plus y plus 3z equals 4. So we are going to use the ALEKS calculator to make our computations a little easier. So first, we're just going to fill this guy in. So 4, negative 4, 1, 5, negative 2, 5, negative 4, 1, and 3. That's actually quite a bit easier to say anyway than the originals, because it's just a little less to deal with. So we're going to use our calculator, and we're going to calculate that determinant. So remember, I got this 93, like magic there, but I had to go into the calculator and type it in to get that 93, or do the cross multiplication method. So now I know the determinant is 93, and I'm going to go to my y column, because again they're asking for the value of y. They can ask for the value of x, y, or z. By chance they're just asking for y again. So I'm going to replace that y column. Instead of negative 4, negative 2, and 1, I'm going to replace it with negative 2, 5, and 4. So I've replaced it. I type this back into my calculator, back under determinant, and I get 90, and then I just bring the 93 down. And again, it's not going to simplify any farther than that for now. If it can, great, you can go ahead and simplify it, but 90 and 93, they technically can both divide by 3. I could have reduced them a little bit, but it's actually accepting that just fine, not reduced. So this was working with Cramer's rule on a 3 by 3 system of equations, and also using the ALEKS calculator to help us calculate the determinant. So I hope that helped, and I will see you on the next video.